Hi, seventh graders. Today we're going to talk about rotations on the coordinate plane. So a couple of things about rotations. Remember that rotations are like turning an object, okay? So a rotation is going to turn a figure around a fixed point called the center of rotation. And so for the examples we're going to be looking at, the center of rotation will be the origin on the coordinate plane, so 0, 0. And we'll rotate in increments of 90 degrees. We can rotate clockwise and counterclockwise. So clockwise, if you think of the way the hands move on a clock, and counterclockwise is going to be moving to the left. And consider each quadrant of that a figure rotates as another 90 degrees of rotation, okay? So what we're going to do first is we're just going to look at some examples of just a general figure being rotated and talk about what the rotations are, okay? So here we started with A is the pre-image and then rotating to be A prime here. And so because we shifted one quadrant, this was a 90-degree clockwise rotation. So if I think moving clockwise, I moved one quadrant over, and so that's a 90-degree rotation. Or we can think of it, if I think going the opposite way, counterclockwise, all right, I shifted 3 quadrants, so that's going to be 270 degrees counterclockwise. So either one of those rotations would get us the same image there. Here we're going to start with B and go to B prime. So if I'm going counterclockwise, that's a 90-degree rotation. If I go clockwise, I'm moving 3 quadrants over. So this would be 270 degrees clockwise. And then here on this figure, going from C to C prime. If I'm rotating clockwise, I moved 2 quadrants over, so that's 180 degrees clockwise. And if I think counterclockwise, I also moved 2 quadrants, so that would be 180 degrees clockwise or 180 degrees counterclockwise. So we're going to look at triangle ABC and the rotation that happened here and complete the table for that. So first of all, let's go ahead and get our pre-image coordinates of A, B, and C. So A is at 2, 3, B is 5, 8, and C is 6, 1. And our image coordinates, A prime, B prime, C prime. A prime is at 3, negative 2. B prime is 8, negative 5. And C prime is 1, negative 6. And so if I look at how we went from our pre-image to our image, it moved 1 quadrant clockwise. So that'd be a 90-degree rotation clockwise or 270 degrees counterclockwise. So if I think going the opposite way, I moved 3 quadrants over, so that would be 270 degrees counterclockwise. So if we look at the values in the ordered pairs and think about how the rotation affected the values of the ordered pairs, here are X and our Y. So A started at 2, 3, and then A prime went to 3, negative 2. And so it's kind of like our X and our Y values switched locations, and then the X value became the opposite. So X and Y switched locations, and the X became the opposite. So if we think of how to write that algebraically, we have our original XY ordered pair. And now in the new one, on my new image, here my X was 2, and then now it's like they flip-flopped. So the Y coordinate goes first, and then the opposite of the X value. So we're going to look at our pre-image and image points again here with the rotation. On this one, we rotated going from our triangle ABC to A prime, B prime, C prime. We moved 2 quadrants, so we can say this is 180 degrees clockwise, which is also equivalent to 180 degrees counterclockwise. Our pre-image points. A is at 2, 3, B is 5, 8, and C is 6, 1. And then after we've rotated 180 degrees, A prime is now at -2, -3, B prime is -5, -8, and C prime is at -6, -1. So if we think of what that algebraic rule is for that 180 degree rotation, our XY coordinate becomes the opposite of X and the opposite of Y. So both of these, each value just became the opposite of it. And we have another example here. We have triangle ABC, so we're starting with that same triangle. If I move it clockwise, it moved 3 quadrants, so this is a 270 degree clockwise rotation or a 90 degree counterclockwise rotation. And our pre-image points are the same points that we've started with the past couple of examples. And then those image points, so now A prime is at -3, 2, B prime is -8, 5, and C prime is at -1, 6. And so again, if we look, it's kind of like our X and our Y flipped, but then that Y value in the new, what was originally our Y value became the opposite in the image. So our XY ordered pair becomes the opposite of Y, X. So if we were to think about what would happen if we rotated an object 360 degrees, so imagine moving it 4 quadrants, that would actually be in the same location. You'd end up back in the same location as the pre-image. And if we wanted to think about representing that algebraically, you would just have XY becomes XY. Let's see, we are not gonna focus a whole lot on 8 and 9. Or 10 right now, so we're going to focus on 11. So summarize the effects of rotations by writing sometimes, always, or never in each of the blanks. So rotations blank preserve the congruence of a figure. So when we rotate a figure, the congruence is always preserved. All right, so it'll always be the same shape and size. All right, As far as the orientation of the figure, sometimes that will get changed. And they will never change the orientation of a figure's vertices. So again, if you think like clockwise, counterclockwise, the way that the vertices are labeled will never change. That's a little bit about rotations. I hope that helped. Have a wonderful day.